Next, we have Ryan Timms, Senior Data Scientist at the BBC. Ryan will be presenting Predicting Retention on the BBC Sound Service using historic user dynamics. In this session, he will discuss how the BBC is leveraging user interaction data from the BBC Sounds platform to predict listener retention. He will share insights into using temporal features such as listening habits over time, alongside static attributes to model user churn as a binary classification problem. Ryan will compare different machine learning approaches, including temporal architectures like convolutional and recurrent neural networks, against static models like XGBoost. Attendees will learn about the optimal strategies for retention prediction and the role of temporal data in improving model performance. Please welcome Ryan Timms in the stage.
Thank you. Good morning, everyone. Thank you to the conference organizers for an awesome week of talks, and also thanks to all the volunteers and everyone working behind the scenes. It's been great, and I hope everyone's had lots of fun. So my slide this morning says time series modeling for BBC Sounds prediction, but I actually want to start by asking a question, which is, should we be doing this in the first place? And hopefully by the end of the talk, we'll all be able to answer this question together. Now, I'm sure all of you have heard of the BBC before, but being an international audience, maybe you're not as aware of all of the excruciating details. So we are something called a public service broadcaster, and this means that we're funded by something called the license fee. It also means that as an organization, we have a mission, and that mission is to act in the public interest, to provide impartial and high-quality outputs, and to inform, educate, and entertain. And I have underlined what to me I think is the most important part of that mission, and that is to act in the entire interest of the UK. And we do this by providing media content across genre and age brackets. But another way in which the BBC tries to provide for everyone is by providing several distinct products. This includes TV, news, sport, weather, and education, but today I'm going to be talking about something called BBC Sounds. Launched in 2018, BBC Sounds is the BBC's audio-based product. It provides listeners with music, radio, and podcasts, and is available both online and on demand. You can get it on your smart speaker, on the website, or on the app, and it's free to use. It has an average weekly audience of 4.7 million users, and just under half of all plays come from on-demand clicks. Now, what I really like about the BBC Sounds app is just how easy it is to use. So you can see here, this is a recording from my phone. I can simply just go in and scroll through the radio network. I can find my favorite show. I can hit pause. I can rewind. But I can also go back in time and find broadcasts from yesterday or 2 days ago. But BBC Sounds is so much more than just a radio provider. It also provides really high-quality podcasts, and it's got a great recommendation system which tells me what I should maybe listen to next. And finally, Sounds also has a music service, so we can pump up the jam while we're coding away. So hopefully that's gone some way to convince you that BBC Sounds is really awesome. It's a product that we want you to start using, but then also to keep using. The work I'm presenting today is a product of the product growth team, and we are part of a wider team which helps to design and develop and deliver the aforementioned products like BBC Sounds. We are a cross-functional squad comprising data scientists, engineers, and delivery managers, and as you can see, we're distributed around the UK. And our team's purpose is largely to build predictive models and metrics that enable product managers to better quantify growth within the BBC. So, on to the meat of the talk. What is retention, and why is it important to us at the BBC? Retention is the opposite of churn, so it is the act of sustained use of BBC products. Whilst retention, I'm sure, is important for all companies, it is particularly important for us at the BBC as a public service broadcaster. As unlike a business, we are not driven by profit. Rather, we try to deliver value for all by educating, informing, and entertaining. If we see very high retention figures, it tells us that we are providing and advertising good quality content across a host of audiences, and this will reflect a modern-day, culturally and ethnically diverse Britain. People might keep on using BBC Sounds simply because they love our content, But we also acknowledge that people are creatures of habit, and when you get out of bed in the morning and start listening to a radio as you eat your breakfast, you're probably going to continue this habit. And finally, there is a practical element of the use of BBC Sounds. We provide news and weather bulletins to inform the public. On the flip side, there are a host of reasons as to why people might stop using BBC Sounds, and often in the literature this is split into two different categories. The first category pertains to the fact that our audience are human beings. There are many reasons why you might momentarily stop using the app. You might fall ill, you might go on holiday, or you might just get really busy at work and you can't listen to your favorite podcast anymore. And at the BBC, there's not a lot that we can do about this. But perhaps more interestingly for us here as data scientists, there's also not a lot we can do. Some problems are just impossible to model. And this in general is called uncontrollable churn. The second, more problematic category relates to our content and how we advertise it. Someone might be a devoted listener to a podcast, but if there's no clear onward journey for them, they might then stop using BBC Sounds. This more serious category is somewhat of a proxy of us not delivering value for all. And maybe simply we're just not reaching our audience through our advertising or recommendations well enough. This is often termed controllable churn, and as a team of data scientists, it's our job to focus on this second category. And so the goal of this project was to provide stakeholders with the probability of each of the 5 million users of the Sounds app returning at some point in the near future. The idea here is if that we can successfully identify people, we can stage some kind of downstream intervention, such as a push notification or changing the order of the recommendation rail. Now, what I'd like to stress here is that we've been really quite ambitious. So we're trying to predict retention for the next week. If you think about how busy your weekly lives are and how much they change from week to week, some weeks you're just not going to have time to listen to a podcast. So inherently, there's a lot of noise and data in our system, and it's quite hard to predict retention for such a period into the future. So we're really kind of going for gold here. But now that we're talking about data, we can start thinking about how we might frame this problem. Here we have a fictional table of activity where gray and black indicate some interaction and white indicates some absence of interaction with BBC Sounds. The first thing we do is go into our data and select a window of interest. We then window it. We then go in and look for periods of inactivity. And as I said before, this work focuses on predicting retention for just a week into the future. We then look at the data leading up to this event. We window it, extract it, aggregate it within the windows, and then feed this aggregated data to our model. So that's the case where someone is retained. And at this stage, I'd just like to highlight how we might be a little bit different from average companies. Sorry, I'm not calling other companies average. From the typical company, in the sense that BBC Sounds is free to use, so there's a very low barrier to entry. It's not like Netflix where you have a subscription. So you can come and go from BBC Sounds as you will. And because there's no financial data attached to BBC Sounds, we don't have any clear signals indicating that someone is getting fed up with our product. All we have to go off of are the user dynamics. But to try and predict retention, we also need the positive case where someone is retained. And this is really quite easy. Again, we just go into our data, we extract it, but here we just look for cases where someone is using the app. And the really nice thing about doing it this way is that if we want to, we can draw an infinite number of positive cases of retention because you just sample and sample and sample. And so we've chosen to model our retention prediction problem as a simple binary classification one. However, what we have done is we've done our best to respect the temporal nature of our problem using dynamically evolving temporal features with BBC Sounds to predict future retention. Our pre-processing pipeline is pretty standard here. First, we deduce that any missing values is a non-interaction with BBC Sounds, so we fill that in with a 0. We then undergo some transformations, apply these to our data before projecting into a PCA subspace. Then, as usual, we split our data into train, development, and test sets, search for the best hyperparameters for our models, and then having found those best hyperparameters, train our final models, and then come on to evaluate it. But this naturally leads us to the question as to how we should best evaluate our model. We want to train our model and optimize it so it will predict retention in the future. And as such, we split our data like so. We have our training data, And then we have our development data set, which is for the future. And finally, we have another test data set, so that we're really trying to respect that kind of prediction problem. And finally, it's just worth saying we keep accounts separate from the train and dev and test sets, so that there's no leakage between accounts. And so what might we expect to see in our data? We could plot the number of minutes listened to by someone over time. And in the case that someone comes back to BBC Sounds, we might expect this to stay roughly constant, or maybe even there's a slight uptick before them staying. In contrast, for someone who's going to leave BBC Sounds, we might see them starting to slowly disengage with the platform. But it's worth stressing that these are merely hypotheses, and there might be some more subtle, nuanced temporal signal, or frankly, no temporal signal at all in the data, which is a good indicator of retention prediction. Come what may, we label our data, we feed it into our models, and we're good to go. So our research question here is, can we get better retention prediction by employing temporal classification models? In other words, can we make use of the temporal features that may or may not be in our data to better predict retention? So here are our candidate list of models. And we can split these into sequence-agnostic models and sequential models, i.e. models which really care about the order you feed data in and those that do not. Our training data comprise 100,000 users up to and including August 2024. And we chose to expose the model to 140 days worth of context prior to a retention or a churn event. And it's worth saying we have a slight natural imbalance in our data set. In terms of the features, all of the results I'm presented today are going to be from dynamic features, which we use to train the model. We did explore using static features, but we found that they were just really terrible at predicting retention. I'd now like to present some of the experiments that we carried out in this project, specifically with the modeling. And again, these can be split into two categories. But first, what I'd like to do is kind of try and motivate why it's worthwhile for us doing this. The first is around accuracy and not upsetting our audience. So we have 5 million people who use BBC Sounds every week. If we are incorrectly wrong by just 0.5%, that means that 0.5% of 5 million people are potentially going to get a push notification and get a bit annoyed. And whilst the stakes are relatively low here, we want to keep our audience happy and keep them on board. The second pertains to cost. As a public service broadcaster, we do have a fair amount of money, but it's not endless. And what we would like to do is we'd like to keep our license fee as low as possible for our audience. And one way in which we can do that is by deploying scalable, effective, and accurate machine learning models. So we can find a model which is nice and cheap and really good, that's great, rather than having to turn to something more complicated. Okay, so the first set of experiments were all about pipeline and model hyperparameters. What I plotted here, hopefully you can see it, is the logistic regression grid search results for L1, L2, and elastic regularization. And in the top panel, I plotted mean test accuracy, and on the bottom, the area under the curve, and the different colors relate to different regularization strengths. But plotted on the x-axis here is a percentage of variance retained in our PCA step. And what's quite interesting is that this doesn't really matter too much before you get to 85% or so. The only case in which it does matter is with the L1 case. Sorry, not the PCA, the regularization value. The different colors here are all roughly overlapping apart from the L1 case in the bottom left. But what's interesting to me, at least, is that on the left-hand side of these graphs, we get peak performance. In other words, when we throw a lot of our data away, we're getting maximum performance. And we see this across both models, both static models. With XGBoost, we see performance peaking at low percentage of variances retained. And it's worth stressing, actually, that logistic regression and XGBoost are doing roughly the same here in terms of dev set accuracy. So why is 70% of variance retained our Goldilocks zone? Or maybe not. Here, I plotted our training data. On the left-hand y-axis, I have the eigenvalues on a log scale. On the right-hand axis, I have a cumulative fraction of variance explained. The eigenvalues are shown in orange, and each of the 10 constituent data sets are shown as thin lines. The mean is shown as a thick line, same for the cyan. But what you can notice here is we have a massive, great big cliff edge. And our interpretation of this is that this is signal and noise. Everything to the left of this cliff edge is signal, everything to the right is noise, because you see the eigenvalues drop by 4 orders of magnitude. If we go into this graph and read off what the percentage of variance explained here is, it's about 75%. So this is why we think this is our sweet spot in our dataset space. We're just projecting noise out of the data. After carrying out a Bayesian hyperparameter search, we found that the optimal temporal CNN comprised small convolutional layers optimized with the Adam W optimizer. And after projecting our data into PCA space, we end up with about 3 virtual channels. Similarly, we found a very simple solution with the bidirectional RNN with using just 12 LSTM units. The next thing we did was look at optimal dataset configurations. I've already mentioned that we exposed the models to 140 days worth of data, and it might seem like I've just plucked that number out of thin air, but I promise that wasn't the case. So here I've plotted the dev set accuracy on the y-axis and the number of days of context fed into the model on the x-axis. And the different lines here represent different dataset sizes. And what you can see is that after about 100 days of context fed to the model, our accuracy starts to plateau. There is a bit of an effect with the dataset size. Unsurprisingly, larger datasets provide better models, but there's much of a muchness to it. The next thing we wanted to do was try and interrogate and probe our temporal models and try and figure out what they're learning or how they're learning or if they are learning. So here we plotted the precision and recall for the RNN and the XGBoost model, but then we did something a bit weird. We chose to shuffle our data before feeding it into XGBoost again. And if we do that, we get exactly the same result, which is good because XGBoost doesn't care about time. In contrast, when we fed shuffled data into the RNN, we see our performance drop. So what is this telling us? This is telling us that XGBoost and the RNN are learning how to predict retention in 2 very different mechanisms. They're achieving about the same performance, but through 2 very different mechanisms. And finally, we investigated the effects of recency on performance. So here on the y-axis, I've plotted the dev set accuracy, and on the x-axis, I have a training dataset rows, training dataset size, and the different colors here represent the distance between our test dataset and our training dataset in months. And what you can see, again, probably intuitively, is that more recent data is a better predictor for retention. But we can also just stitch all of this data together and massively scale up our dataset size. And if we do that, we get the best performance, but only by a small margin. You can see the uptick here is really quite minimal, but what we do get is an improvement in robustness, so there's less jitter in the validation folds. So on to the final results. In terms of accuracy, logistic regression narrowly wins. It outperforms XGBoost, and for area under the curve, there's a dead heat between logistic regression and XGBoost. We see a very similar pattern in terms of error metrics, with the RNN actually being the worst. So I started this talk by asking, should we bother doing time series modeling for BBC Sound's retention prediction? In my opinion, at this stage, the answer is no. Explicitly modeling the sequences hasn't really kind of paid dividends just yet, but this is not to say that representing the data in this temporal windowed way is useful even for the static models. We're giving it a lot of temporal context. So this means that we're going to deploy our logistic regression model, keep it simple, and the reason why we're going to do this is because it's performant, cheap, reliable, and most importantly for us, interpretable. We can go into the model and tell our stakeholders why people might be staying with BBC Sound or why might they not be. But a kind of interesting intellectual question is now, why aren't we doing better with the temporal models? Are we at the point of diminishing returns? Maybe. As we've seen, the dataset size only has a small impact on performance. But inherently, what I think is going on here actually is that we're trying to predict a really, really hard thing, which is retention for a very short period of time. We all have busy lives. There's a lot of chop and change from week to week. And so churn prediction is just a really hard problem, and I think that's what we're seeing here. And it's also what you see in the literature. You see people going and using really, really complicated models to try and predict retention, but often there's a very quite disappointing uptick in performance over baseline models of like 1 or 2%. However, just to put our cards on the table. One thing we haven't really done yet is really exploit the model to seasonality effects. And whilst we're doing temporal modeling, we haven't taught our models to tell the time yet. So we're hoping that once we bake in the kind of temporal, the exact time into our data sets, that maybe these more sophisticated architectures might improve performance a little bit, but our expectations are set fairly low because we acknowledge that there is an inherent performance ceiling in our data. In terms of next steps, we'll be going on to production. In parallel, we'll be doing the seasonality work, which I just mentioned. But most importantly, we are going to be looking at our feature importance, feeding this back to our radio producers and stakeholders, and letting them know why people are hopefully identifying successfully why people are turning away. We'll then be able to start to answer questions like, is our model good enough? So the BBC currently doesn't have a churn or retention prediction model. Once it's in deployment, we'll be able to start doing experiments, and we can then maybe look to iterate and improve our model and do some error-based learning. And finally, I'd just like to acknowledge that there's a whole host of other potential modeling techniques which we could use, such as bandits. And as we've seen, our static models and dynamic models are achieving basically the same accuracy through two very different mechanisms. So perhaps combining these in some kind of ensemble approach might leverage better accuracy. And there's some work being carried out by a man called Fraser Douglas, who's also looking at a completely different way of modeling this, not looking at time at all, and seeing if popularity is a good predictor of retention. So watch this space. So predicting retention is a really hard problem. Our model accuracy will always be capped due to factors which are impossible to model, and this falls into the uncontrollable churn category. But that being said, even with really, really simple architectures, we, on the face of it, think we are achieving fairly good accuracy, and we'll find out soon enough when we go into production whether this is the case or not. And just a bit of a practical tip to you guys if you're ever working in churn, I think keep it simple, but also just look at your data, because we found by far the most important hyperparameter was a percentage of variance retained in the PCA step. And just to reiterate, in our use case, we tried more complicated models, we tried to go for it, but we ended up right back at the beginning with the most simple logistic regression model, which is really good news for us because it's simple, it's interpretable, it's cheap, and we can productionize it easily. And with that, I'd just like to say thank you very much for your attention, and thanks again, guys, the organizers and the Sound Desk for an awesome week of conferences. Cheers.
Thank you very much. Do we have questions? Yes? Yes, please. Mm-hmm.
Thanks for the nice presentation. I just want to clarify one information. So there was a slide you showed that having more data from the past, it does not necessarily improve the prediction. Is that correctly understood?
Yeah, so basically our interpretation of this, and you see this in other problem spaces as well, you see it in recommendation systems quite a lot. If you start to train your model on really historic data, you just confuse it, or not confuse it, you distract it. And actually what we've seen, again, in this problem space, is that most recent data is the most relevant for predicting retention. It's how you behaved last week or 2 weeks ago as to whether you're going to come back next week, we think, rather than what you did 6 months ago. That being said, I haven't shown it here. There is some kind of annual seasonality. So we found that data, if you're trying to predict retention for October 2024, data from October 2023 is quite good. So I think the kind of impact of recency kind of goes like this. It's like a U shape. And most recent data is really useful. Then it starts to get a bit rubbish. But then you come around again, and then you get to this time last year, and it starts to become useful again. But it will depend on your data and your problem space.
Thanks.
No problem.
Thanks again for the presentation. Yeah, just also to clarify understanding about the split and the labeling technique you mentioned, 60%, 40%. So you made some assumptions of the retention in the kind of based on engagement, on any engagement. So that was your kind of 1 or 0, or yeah.
Yeah, so our definition of retention is simply, do we see these people next week? Yeah. If we do, we give it a 1. If we don't, we give it a 0. And again, this might be where like our specific use case is slightly different from companies where, again, they have that strong signal of I've cancelled my subscription, I'm really upset, I'm going. We don't have that, we just have, oh, we haven't seen Barbara from Swindon for 6 weeks, where's she gone?
Yeah, thanks a lot.
We have one more question, yes?
Hi, thanks for a great talk. You mentioned that the static data were disappointing. Like, what is available to you? What did you try? Geographical or something?
Yeah, so we have geographical data. We also have an approximation of age. We've got a bracket. We also have an approximation for demographics. So like what kind of person you are, what you do in society. And we also have gender, but we didn't bother modeling and using gender because we thought that's not going to be a useful predictor of retention. And if it is, then it starts to get a little bit interesting ethically. So we didn't.
Yes, please.
Hi. How do you plan to this inference step in deployment? So are you building an API real time or in batches?
So it doesn't have to be real time. So our stakeholders are just internal radio producers and people who work with BBC Sounds internally. So it doesn't have to be like particularly quick. Which I think literally just going to provide a list of return probabilities to our stakeholders.
So every day for all 80 million or how much you say users?
5 million. I wish it was 80
5
million,
million,
but
sorry.
yeah. No, I think once a week. The idea being, we do it once a week, then we can see who in the next week is going to come back, and then also that week gives us like quite a nice time scale to stage some kind of intervention.
Okay, thank you.
Thank you.
Very nice presentation.
Cheers.
Yes, please. Okay.
Sorry,
Yes,
one
okay.
other. Hi. Thanks for the great presentation. One question I had was, I mean, the model is great, but as important, I mean, just as important is how you deliver it, right? I know you mentioned push. Is there any other ways you will deliver this? Like, how are you going to action the clients, basically? That's my question. And do you have any idea about what kind of effect it is going to have, or like expectations about it?
Good question. I mean, we're starting from a standing start, so there is no churn prediction at all at the moment at the BBC. So something's better than nothing. I think it's quite hard because, again, like BBC products have a very low barrier to entry. It's completely free. So if you get a push notification on your phone, is that going to make you engage? I don't know. Where I think we will see potentially a bigger impact is with working with our recommendation team. So if we're just delivering or advertising irrelevant content to our users, if you're really into history and we're giving you drama, hopefully this metric will go some way to like raise a flag and say, something's not quite right here. So those are the kind of two dials we can turn to try and stage some kind of intervention at this stage, but I'm sure there's more which Martech will have better ideas of. Thank you.
Thank you very much.
Thank you.
Thumbs up.
Cheers.
And thank you for sharing your knowledge and experience with us here
Thank you so
and
much.
being a part of Data Science Conference
Cheers.
Europe 2024.